Hi, this is Mason with CSTactical.com. We're here at US Optics in Southern California with Jeff from US Optics. Jeff, what are we going to be looking at here today?
Well, Mason, I'm going to be giving you a quick tour of our facility and show you how these scopes are put together. I'm also going to show you a few new products that we have in development.
Great. You want to lead us in?
Sure.
All right, Jeff, so we're here at the beginning stage of building a scope. Tell us about this.
Well, Mason, right now we're in our machine shop where all of our raw aluminum and brass and steel comes from local vendors, gets deposited in our warehouse, and then we'll start doing the machining process. Depending on whether we're going to be making bodies, knobs, rails, rings, mounts, lens housing, it's all done under this roof. You'll see here that I have the beginning of a 1.8 to 10 T-PAL body. Right now it starts off as just a raw aluminum tube, and the end result will turn it into more of the scope shape you see on a rifle. This is actually only two processes into the actual scope machining section. There are two other processes on these machines that need to be done before it goes into bead blasting and then anodizing. Currently our machine shop has 3 CNC lathes and 2 CNC mills. We have a new CNC machine on the way which is going to increase our production capabilities here in the machine shop and hopefully increase the production and scope output of our company. The mills do most of the drilling and tapping and facing of our material, where the lathes do a lot of the body work and circular work of our scopes. Today our machines are working on scope bodies, knob components, and objective housings. Our mills are working on scope rails and the finishing work on the knob components. Alright, so what this machine is doing is it's taking the finished products from the lathe, which are being done on our HAWs, and it's doing the finishing work by not only drilling the 2 top holes and threading them, but also the hole on the side that the detent will eventually be inserted into, which gives the knob its actual click. The next major process in assembling a scope is to start working on the knobs. Here an assembler will choose a particular build and start gathering the components that will be required to complete that build. Starting with the knobs, the assembler will start installing the clicker rings, bushings, springs, and feet to get the knob or the scope ready to go into the clean room. Everything laid out on this towel is one component of a complete EREC knob. Here we have the detents, set screws, the actual foot of the knob itself, the clicker ring that has the teeth which gives the knob its clicking feel, O-rings, and spools. Right now we're in the laser engraving room of the US Optics facility. This laser engraver is responsible for doing all the laser marking on all of our scopes. So every number, dial, or line you see on a US Optics scope is done on this machine. Knobs, dial tops, power rings, ranging rings, even the serialization and the logos that you see on our scopes are done here. One of the newest products that we've developed here at US Optics is our new dual focal plane 1:4 power. This new scope actually has a reticle in the first and second focal plane, which will work together to give the end user kind of a dual role, close quarters and long range precision scope. The reticle in the second focal plane will act as a red dot style sight that you would see in an EOTech or an Aimpoint, and the reticle on the first focal plane will have scaling that you would see in more of a long range precision scope. This will give the user the ability to not only range targets or hold over at any magnification power, but it also gives them a good large target to view at 1 power and get the reticle on target. The scope is currently not featured on our website, but if you are interested in this model and you want more information, feel free to give us a call or shoot us an email. We will also be developing a similar design in one of our higher magnification scopes in both our 17 power and 22 power models, which will be great for the competition shooter. So now that the knobs have been placed inside the scope bodies, they'll enter the assembly room. This is where the technicians will start working with the lenses, doing lens cleaning, and do the finishing work on assembling the scope. The first process in that is starting with the eyepiece housing and the eyepiece lenses and working with the erector and reticle. Technicians will clean the reticles and all the lenses with a combination of acetone and medical grade Q-tips. There's a variety of other cleaners out there, but at US Optics is what we found works best. One of the latest steps in increasing the quality of US Optics products is adding this new microscope. This microscope has a 50 times zoom ratio, which allows a technician to inspect each lens even closer than before. It also allows the technician to measure the thickness of each line and the spacing of each reticle line. So this right here is an erector system that can be found in any rifle scope. This particular one is for a variable power scope and controls the magnification power of the scope by allowing the user to adjust an internal lens, adjusting the focal point of the lens system. Turning it counterclockwise will adjust it to the high magnification setting, and turning it clockwise will start decreasing the magnification. In some respects, this can be considered the heart of any rifle scope because it is what moves the erector or the reticle up and down and left and right when the windage and elevation knobs are adjusted. It also controls the magnification power. The next major step in the assembly process is to check the subtension of the knobs in the reticle. The technician will use this setup as well as a chart at the far end of the building to check the subtension of the reticles and knobs and make sure that they're either equating to the MOA, inch per 100 yard, or mil click values and line spacing that they should. If everything checks out here, the knob will be sealed and go into the quality control process. The last step in the build process before the scope is actually shipped out the door is quality control. This is where the scope is inspected for clarity, resolution, tracking, and proper subtension before it is passed and delivered to a customer. Here our quality control manager will check the subtension of each of the knobs, check the subtension of the reticle, make sure the scope has a resolution that's acceptable to US Optic standards. If anything is found to be out of US Optic specifications, the scope will return to the clean room and be repaired by the assembler. And that brings us to the final stage of the US Optics build process, which is sending the finished product out to the customer.
Outstanding, Jeff. Well, thank you for giving myself and our customers an inside look here at the operations at US Optics.
Well, thank you, Mason. I appreciate you and your customers' time looking into what we do here, and hopefully this shows you what a handful of individuals down in Brea, California can do to produce some of the finest scopes in the market.